lights and you walking up.
Good morning.
Morning, morning.
Good morning, everyone. There we go.
There we go.
Thank you very much, Elliot. Well, good morning. How are you all today? Well, that's good. It's always a nice day without mayflies everywhere. But I'm John Mann, Director of Education for Lakeside. And this year, of course, we're celebrating the culture and geographic regions of the United States. And in week 5 of the lecture series, we will explore the region of the U.S. known as the Southwest. It is also, I'm very sorry. This area is also known for its dramatic desert scenery and its blend of cultures. And it's also known for droughts and flash flooding. And we're fortunate that today Rob Dale is here to share stories and explanations for the weather in this region of the U.S. Rob is a meteorologist and emergency manager. Rob spent a decade at WTVG in Toledo, then transitioned to emergency management and currently is the Deputy Emergency Manager for Ingham County, Michigan Emergency Management. He also is an adjunct professor for the University of Maryland in the Emergency Management Program. I would ask if you would please mute your cell phone ringers if you haven't already, and help me in welcoming Rob Dale to Orchestra Hall.
Time with the meteorology. I'm not going to make you a meteorologist, but I'm going to walk through some of the things that happen, some of the things that I look for when I'm forecasting the weather, and then we'll get in some of the events that have happened over time. So this was my formal title because I like saying mega drought and flash floods all in the same sentence, but this is really what it is. There's a big change going on in the Southwest U.S. Their climate patterns are changing. Their overall weather is different than what it was just 50 to 100 years ago. Really, when we look at overall big picture changes, the Southwest and the Great Lakes are the big areas. I'm going to go into the Southwest today, so I won't give it away. The Great Lakes, we're losing our cold winters. If you think, hey, the winters weren't as bad as they used to be, we still get one. Last winter was cold. There's no doubt about that. But in general, our winters are warmer. Our nights are not as cold as they used to be, which has a big impact on recreation. If you're an ice fisher in northern Michigan, you don't do that job much anymore because there's not as much ice. We have issues with bugs. The bugs do not like below zero nights. We don't like them either, but unfortunately they kill the bugs. So when we don't have below zero nights in the winter, bugs are worse in the spring. So parts of the country that are most impacted by the changing climates are us in the winter and then the Southwest U.S. all year long. So I'm going to talk about how that's changing and then what impact that has on the residents of those states. They do have 4 seasons, just like we all do. Their seasons are really dramatically different weather setups and scenarios and patterns. So in the winter, that's when they need to get their snow. They need to get snow because they're so very reliant on snowpack for their water supply, for refilling the reservoirs and rivers. So that's a big issue, and they are seeing indications of less snow in the winter. So you have less snow, less to melt off, we'll have issues downrange. In spring, that's when it quickly dries out. There's very little precipitation for much of the spring. So everything that grew over the past year now dries up and gets ready to burn when it comes to wildfire season. So spring is fairly quiet. It's supposed to be mild. It was not mild this spring. I'm going to show you some stats on how this spring has gone. But it's supposed to be mild. And then summer, that's when we get these heat waves, these major heat waves that can last weeks or longer. And then we also get rains, monsoon rains. If you've heard of that before, I'm going to walk through what monsoon actually is and how that works. And then finally, autumn again. Now you've gotten back to this dry season. So we've gotten growth in the spring, or we've got growth in the summer with the rains that have come through. Then it quickly dries back up. It settles in again before winter starts. So a lot of times we'll see that second surge in fire patterns and wildfire issues come in the fall. So plenty of variety of weather. Again, they get the same weather we do. It's just very sectioned. It's very siloed from season to season. So I'm going to go through just a little meteorology for you because I'm going to use some terms. High pressure is when the air is sinking. So we've got high pressure coming in, air sinks that when the air gets to the ground, it rotates clockwise. So this is the way the high pressure systems rotate clockwise. On the other hand, low pressure, that's our storm system. That's what we've got coming through later today, which might kick off some showers and thunderstorms. Low pressure air rotates counterclockwise and it rises. So rising air in low pressure, falling air in a high pressure, compressing down near the ground. And here's what it looks like when we actually draw weather maps. We draw these lines, they're called isobars. They're lines of equal pressure. So when the first thing I ever do when I make a forecast is what's happening right now. So I will go through and manually draw these lines to show where the highs are, where the lows are. But just remember that the main concern with high pressure is that we've got this clockwise rotation going around the high pressure system because that sets up everything weather-wise that occurs in the southwestern United States. And how do we know what the pressure is? I mentioned this last time. I want to get a little more detail. We will launch balloons. So we have a little balloon that they tie a shoebox-sized weather instrument package to. So twice a day, usually around 7 or 8 in the morning, and then 7 or 8 at night, the Weather Service offices across the country launch these balloons. So they'll go up to about 100,000 feet. As they rise, the balloon expands. Eventually it pops. It's got a little parachute that floats the weather instrument back down to the ground. But it's sending this information via GPS, via radio, back to the receiver site. So this morning, the closest balloon to us is over by Detroit, by Pontiac, Michigan. So they launched this balloon at 7 a.m. and what it does is it shows us what the temperature is as we go up in height. So this is the red is the temperature. It started off at 81 degrees. This is the Flagstaff, Arizona. This is not us. The dew point, the amount of moisture in there is very, very low. So very dry. There's a wide gap between that. And then what we also do is we look at the winds. So as we go up, if you're in aviation, you're familiar with some of these, but as we go up, every line is 10 knots of wind, or about 15 miles per hour. So as we get up high, we're looking at 50 mile per hour or 60 mile per hour winds. So we plot all of this information on a chart then to give us an idea of what the big picture weather map looks like. So this caught everyone's interest last time. I got a quick video on what the actual weather balloon process looks like so you can see from behind the scenes.
Make sure that the radiosonde at the office is picking up the correct number of satellites. So we let it sit there for a few minutes to make sure it's catching all the correct satellites, make sure all the temperature data is correct. Once that is ready to go, we can bring the radiosonde down here and launch the balloon. We attach a parachute, so when the radiosonde does fall to the ground, it won't hit anybody, hit anything, cause any damage. After that, we will attach the parachute and the balloon to the radiosonde. After that, we launch the balloon. It gets to about 100,000 feet, takes 90 minutes to pop, and then we quality control and monitor the data for the next 90 minutes. These observations, after we take them, are carefully quality controlled by our staff, and then all of the observations go into our models to help us forecast. We also use the raw sounding data to actually help us with severe weather, rain, snow lines when it comes to winter weather, and also helping us out with various other temperature and dew point predictions.
So that's the process behind the scenes. Again, I got to do this once up in Gaylord. There's an office there where I was near vacation, but that's how we get our raw data. And then we plot it. So here's a map. This is showing where the jet stream is. If you remember from my last talk, the jet stream is the main driver of our weather pattern. When we look for the jet stream, we look for these close lines oriented west to east. So we've got a strong jet stream up to the north, but you'll see as I go through, this starts in May and goes through September. Let's watch what happens down in the southwest US. Notice it pushes the jet stream away and it sets up a high pressure area right over it. So there's no changes in Arizona's weather for an extended period of time. There's no big picture. There's little stuff that happens now and then, but the big picture is just once that heat dome sets up, that high pressure area, it sits there for weeks, if not months at a time. And here's what's going on. So you've got this high pressure, remember the sinking air, so it evaporates any clouds. It pushes any clouds out of the way. So it's sunny skies. It heats up the ground, which heats up the air around it. The air rises, it heats up once more, comes on down. We've got this sinking air, it continually heats this process. So when we talk about a heat dome, we're going to talk about that in Ohio next week. You're going to feel the dome next week because we're going to have one. Theirs stays a lot longer. So if you really like heat, that's the place to be because Arizona, once they set up, they're here for again, as I said, weeks, if not longer. Back in 2023, Phoenix spent 31 days in a row where every day was 110 degrees or higher. The previous record was 16, or 14 days, I'm sorry. And then notice also at the issue, daytime we can kind of handle, but at nighttime there was over 2 weeks where it never got below 90 degrees at night. So there was no recovery. There was no recovery from this long stretch. And again, this is new. The previous record was 2 weeks, we blew it. We blew it away. So a month straight, Phoenix every day was 110 or higher, with half of those days it never cooled off below 90. And that just has dramatic impacts on humans, but on the plants, on the animals, everything else that relies on some cooling at nights, it just didn't happen. And here's a fascinating loop. So I'm going to start this loop, but the time you'll see up at the top, these are all taken around 2 to 3 in the morning. So we've got almost 3 weeks of data, but watch the temperatures. So blue are cooler, those are in the 60s and 70s, reds are the 90s. Watch what happens as I loop this. As we go through time, this is at 2 in the morning. The ground is not cooling below 85 or 95 degrees, especially where you can see there's the Phoenix Airport. You can see that's very hot. Downtown Phoenix remains very hot. The mountains remain very hot, so this extended heat really just breaks people down. I mean, we can all handle a little bit of heat, I get it, but at some point there's just too much. And Phoenix is often seeing too much in the form of heat. And this year, if you're out in the Southwest this year in March, March had the earliest heat warnings ever this year because they had stretches of days where it was over 100 degrees in March. Remember I said that was supposed to be their quiet season. They were supposed to just settle in March and then get warmed up. That started off with a bang in 2026. So extreme amounts of heat in the Southwest U.S. That's kind of why we were cold. All the heat was bottled up on the west side of the United States, so we really didn't have a spring in much of the Great Lakes. We went from winter to summer-ish, and then the last few weeks back to spring, but nonetheless, all the heat was here in the United States. It just was on the west side, so we didn't have much warmth in the spring because it was all confined to the Southwest. This chart plots how things have changed over time. So how many days per year have they exceeded 110 degrees? We're already at 5 so far this year. So black is normal. 5 is already above normal, and we're not even to the heart of the season. So this is 110 or higher. How many times have they stayed over 90 degrees for the entire day? Already once this year, but you see the average is 7, but it's gotten pretty bad in the past. The most of just 2 years ago, they had a total of 39 nights where it never got below 90 degrees. So just again, it's bad on infrastructure, it's bad on humans, it's bad on your AC system. There's a lot of bad with this extended heat, especially when it does not cool down in the evenings. Because again, the other thing is we don't think we need to drink. If you wait until you realize you're thirsty, it's too late. Every one of us at one point or another has had some sort of heat stress go through. So whether it's been severe enough to be hospitalized is another story, but we've all had that point. If you are outside on a hot summer day and think, I'm thirsty now, it's too late. Still get a drink. I'm saying don't ignore it, but that means you've passed the point where you should have had some water already. So stay hydrated, stay indoors as much as possible. Again, next week, it's going to be very, very hot. So do things in moderation as need be, because that heat really does take your energy away without you recognizing it before that happens. But let's get into rain, because I talked about floods, and so we need to talk about floods. So this is the daily precipitation total for 3 sites in the Southwest. We've got New Mexico, two in New Mexico and 1 in Tucson. Notice very, very little rain to none for most of winter and spring, and then all of a sudden June, July hit, boom, they peak up, and then it's back to normal. Same with Albuquerque. Little to none for an extended period of time. We get all of it in the mid part. Tucson, Arizona, same story. Everything comes in July, but Tulsa, you know, it always rains in Tulsa. And then that's our pattern as well. We get showers and thunderstorms all season long. There's no real peak in Michigan and Ohio and Indiana. There's no real area of time where it gets all of the rain at once. But all three other sites, yeah, the monsoon season is when they get almost all of their precipitation. And here's a good map that shows anything in green gets more rain in July than June by a significant factor. You can tell where it is. The July peaks in the southwest U.S., also peaks in the southeast U.S. because they have typical afternoon thunderstorms. If you've been to Florida in July, you know it rains just about every day and then it's done. In the Great Lakes, we're not really that big of a difference. It's, you know, June and July, we get thunderstorms equally in both months. But also the Great Plains, that's when they set into their drought pattern. So farmers certainly take awareness of drought. But July, August, those are the peak months for rain and precipitation in the southwest United States. And here's why. So again, the water cycle means, hey, we've got evaporation from the Gulf. So I'm going to show some maps. We've got a little bit of water contributed from plants, but then it condenses into clouds and it comes back down as precipitation in the mountains. In the winter, it's snow. In the summer, it's rain, and then it rushes back down and comes back into the surface runoff. So the water cycle is just a continued process. That heating of the air helps melt the water, evaporates it, condenses into clouds, and then rains back down. So here's what it looks like for moisture sources. Most of the moisture comes from the Gulf of Mexico, America, whatever you want to call it, the Gulf. Let's just go with that. Who's been in the Pacific Ocean? Is Pacific Ocean water warm? No, it's freezing, but what's different is the Baja Gulf. The Gulf of California is quite mild. So if you were to swim in here, it's much warmer air because that warmer water, that's what evaporates more quickly. So they don't get it from the Pacific itself. They get the Gulf of California off Baja is where that comes from. And then some moisture out of traditional storms that come out of the southern plains, but this is going the wrong way. Most of our systems go west to east. Theirs go east to west, because I'm going to show you some of the maps that have this indication. So their main sources, again, the two Gulfs and then the plain states when a backwards cold front comes through in a weather maker. This shows sea surface temperatures, so the temperature of the water. And again, if you've been in the Pacific, yes, it's cold. But in the Gulf there, you see much, much warmer where temperatures are in the 80s or 90s in Fahrenheit. So that's a good supply of that warm, moist air is what feeds in the thunderstorm complexes that form. So here's a better map showing, again, the circulation around it. So what this is telling us is that the winds coming out of the east are bringing this moisture out of the Gulf, wrapping it around, bringing more moisture out of the Gulf, and then bringing it down to the southeast. So in June, this is June time, where most of the monsoon rains set up near or south of the country border. In July, though, you can tell. Where's it centered? Right over the southwest United States. So we've got the heat, but now we've got that moisture source coming at the same time. So we'll see the increased number of hot days and then the increased number of rainy days coming in July and into early parts of August. Here's a satellite map. So anything in colored in white are clouds and then moisture. This map is actually showing the level of humidity in the air. The red is dry. So if we watch closely, we can see that clockwise rotation as it's going around that center of high pressure in West Texas, south of Lubbock and down towards El Paso. That's where it's centered, but it's bringing all this moisture in out of the Gulf, bringing more moisture up out of the second Gulf, and then wrapping it around. So it's feeding all this moisture from the south and pushing it into the southwest United States as it wraps around this high pressure area. Again, remember, the clockwise circulation brings that moisture up out of the south and out of the east. Here are the typical weather patterns. Again, most of the time we've got that high pressure centered somewhere over Texas. So it's bringing that moisture from the south and some of the east. Sometimes what it does is, again, a traditional thunderstorm comes up because the high pressure system moves off over to the west, over towards Nevada or California. So that's the high pressure is kind of like a block. It doesn't let storm systems move through, but sometimes it meanders on its own. So in cases where it goes off to the west, we get more traditional thunderstorm complexes. It just looks backwards to us because most of ours, again, come from the west, and these are coming from the east. Another pattern will happen. Sometimes we'll get two separate high pressure systems. So we get the main monsoon high pressure over Texas, and a second one that forms over Southern California. It kind of traps the moisture in between. So it sits overhead and rains for an extended period of time. I'm going to show you what that looks like. And then finally, sometimes we just get some good old-fashioned storms off the west coast that come on through. So they do have traditional west to east weather well, but these are really the four primary ways that the southwest United States gets its precipitation. And because the elevation changes, that pushes the air up. There's a lot going on this map, but what it's trying to tell us is that the water comes in off the Gulfs, that warm, moist air. As it rises, the air cools. When air cools, it simply can't hold as much water, vapor, and so it comes out in clouds and then eventually rains. So that elevation changes have a big factor on thunderstorm and the way storms work in the southwest United States. Here's what happens, though, with the rain. Is I labeled it rain bursts. So we'll see in the top one in Deming, New Mexico, they hit nothing other than a couple of sprinkles through June, and then July they had 4 days in a row of ½ inch to an inch, a gap, and then they got almost 2 inches, then a gap, and then a couple of days with a £1/4 inch, and then a gap, and then, you know, that's how it happens. They don't get a steady rain day for the most part. They don't get a rain out day. They get it all, it's again, almost Florida-like-ish with this extreme rainfall amounts that come on through. And we're seeing with time that when it does rain, it's raining heavier now than it did 50 years ago. So even if the overall rain amounts aren't changing that much, when it comes down and these bursts cause more flooding problems because we've got this heavy amount of rain coming in a short period of time. Many of our infrastructure systems, our sewer systems were built 100 or 150 years ago when rain was different. So they simply can't handle what we put into it today. So rain bursts are an issue. And there's a variability. Again, we have standard weather patterns. It doesn't always change every year. And as you can see on the green line, the overall average rainfall in New Mexico has not changed much. Generally speaking, around 5 inches of rain per year is what New Mexico gets. But notice when the peaks and the valleys have happened. We have 70 years of data. The driest on record was in 2003, and then the wettest on record was in 2006. It seems something has changed in our weather patterns in the last 20 years. That it was fairly variable, but nonetheless within that realm, and then now all of a sudden this century, we're breaking records. We're setting record lows, and we're setting record highs in our variability. Extreme rain events, that's really big for us. Who's been here for our flood events so far in Lakeside? I think we've had 2 this year with the big 2 or 3 inch rainfall events. That's happening across the Great Lakes for the most part. We're getting a lot of these intense rain events, but Southwest US is seeing the same thing, that when it does rain, you know, the numbers aren't changing when you average it out for the entire year, but when you look at when it does rain, it comes through, and it comes through heavy. And our sewer systems, again, our water flow systems were just not set up to handle those extreme events. And we're seeing that when it comes to flooded basements, flooded roads, and issues along those lines. They do have big events. This is in Folsom, New Mexico. Folsom was, it was the largest cattle stockyard west of Fort Worth back in its time. It was a very big community. Changed its name when the Grover Cleveland Alexander visited, and then his fiance's last name was Folsom, so they changed their town name. I'm not sure why towns changed their name, but they had 14 inches of rainfall in a short time span. So again, disasters have always happened. We're not saying they didn't happen in the past, but you can see some steer there trying to get through. You can see significant, there's a water overtopping a dam that they had built. Killed 18 people. Again, this is a quick event. It came through back, as you can imagine, in 1908. There wasn't a lot of weather forecasting going on in the southwest US. So it was a bit of surprise. Sarah Rook, switchboard operator made famous back in this, she called, there are 800 people lived in that town, and she called everyone she could with what phone system. Since they were a big industrial area, they did have a little more phones than most did at that time of the century, but nonetheless, she did her best. To say only 18 people died out of 800 is fairly good. And then afterwards, George McJunkin, if you've heard of him, he had grown up a slave, became a cowboy after Civil War. And as he was going through, he came to help with the recovery efforts, and he found some extinct bison bones that everyone thought didn't exist, and then they found an arrowhead in one of the bones. And so they were able to use that data to show that North America had been inhabited 7,000 years prior to what everyone else had thought at the time. So some good did come out of that. For Sarah, actually, they still have a memorial in Folsom. It's a ghost town now for the most part, but switchboard operators across the country sent dimes, and because that's what phones took at the time, and sent dimes to create a memorial for her. So if you ever happen to be by Folsom, you'll see that. 1997, a horrible flood. This is called Antelope Canyon. That is not an AI picture. That's an actual picture from the canyon on a beautiful day. You can imagine why people want to go in there and tour it. But as they were doing it, thunderstorms about 7 miles away dropped 4 to 8 inches of rainfall in a very short period of time. So it was sunny where they were. It was a beautiful day where they were. There were some forecasts that said floods are coming, but it's in the middle of nowhere. It's before cell phones. There's no way to tell people that floods were coming. So as they're in this cave, this canyon, a 40-foot wall of water came rushing down. So unfortunately, lots of lives in that. There were ladders. Some people heard it, but it was 100 feet to get to the ladder. They didn't have a lot of ladders. There was no regulation at the time. It was simply, if you want to go tour it. Because of this event now, it's changed. You have to have a formal trained tour guide. It's paid a national park, so you have to go with someone that's trained on that. Yeah.
I'm sorry for the interruption,
Yeah.
but I went through that canyon
Oh.
and they told a story about, I think it was PBS, set up cameras in there so that they could film a flash flood, and they never found the cameras.
Really? Oh.
It must have been this event. It was about the right time.
Yeah, so there was very little to show. Again, we didn't have phones in the day. I do have a similar event. It's another part of the park here to show you what it looks like. But this is, again, when he pans up real close, you'll see it's a beautiful day outside. It's sunny. Again, this storm in this particular event was 5 or 10 miles away. But imagine you're walking in a dry, or it's normally just wet, but it's not running water. Imagine you're walking down a dry riverbed, and then this comes up to you. So yeah, just an immense amount of water in a short period of time with no warning. Like, you may have heard it, but if you weren't ready to do that, and so that's why there's a big preparedness effort now in those areas to let people know, to check the forecast before you go out. So I've talked all about water, but then I talked about what happens when you don't have water. So now we're worried about the issues from fires. So weather's a big contribution, the topography, the ups and downs, the mountainous areas allow the fire to rapidly spread up it. And then fuel. You've got these, I talked about, when you're in a drought, you've got all this shrubbery that grew and now is dead, and so it's ready to burn. Active fire seasons, a lot of times they get what are called dry lightning strikes, so thunderstorms with very little rain. So they get the lightning from these storms, which will start fires. They don't have the rain alongside it at the same time to put it out. And then who's breathed some smoke from wildfires before? This summer's been good, but the last few summers, especially Canada feeds a lot of us, but we've had Southwest U.S. smoke come our way as well. So even though we're thousands of miles away from the fire, it certainly can impact your breathing. This is an interesting story. This is New Mexico's worst fire season ever. It was back in 2022. For reasons that no one will ever say, the Forest Service decided today would be a good day to burn some brush for the fun of it, and it got out of control. They were burning in 60-mile-per-hour winds. Never ask why. It burned over 500 square miles, so about the size of Ottawa County was burned entirely down, almost 1,000 structures. Here's a quick video of the recovery efforts.
FEMA is only one. They offer funding to other agencies, including the U.S. Environmental Protection Agency, the Corps of Engineers, and lots of state agencies as well.
And that was a prescribed burn that had been scheduled since the year before.
The wind gusts from February to April were 60, 70, 80, up to 90 miles an hour on any given day, and they still went ahead and did that.
In this community, they rely a lot on natural resources, hunting of elk in season, for example, and growing food for their cattle. And every community is unique. I think agencies are getting better at understanding those unique concerns, and we need to keep working to address those concerns as they come up in the age of climate change, which is already here.
I said, when we were fighting fires, we didn't backburn. We didn't stand at the road and backburn. They actually dropped us off at the fire in the helicopter, and we fought the fire. We went with water hoses and chainsaws, and we fought the fire and we tried to stop it.
They were backburning on the back of this canyon here. The flames were up to 400 feet high
Yeah, so the documentary is interesting because the federal government has been slow to recover or to fund recovery because it wasn't a natural fire. So they caused it, and that's not qualification for a disaster when the government starts a fire. So it's a free documentary called Welcome to Mora, if you're interested in it. Just a crazy story. But what happens then after fires? We burned all that, and what does the ground look like after it's been? Anyone seen wildfire after a fire has been through or the ground? What is it? It's black. It's hard as cement. So the next time rain happens, what does it do? Runs off a lot of that. That's going to look like that water I showed you in the canyon flood. It's going to be all full of debris and junk as it comes on down the fire side. So that's a big issue after wildfires, is then worried about flash floods, events that might not have been a big a deal when the trees and the brush and shrubbery were there, and now are a big deal after the flood risk. And the smoke. So these are some graphics that will show this one. This is straight out of Canada, but this was last year when we had those few days where the sunsets were pretty. Not the lakeside sunsets aren't pretty our way. The problem was you smelled the smoke. And then we actually have computer models that will simulate where the smoke is, so we can track the smoke, because it is a bit of a particulate. It stays enough in the atmosphere that we can measure it and see where it's heaviest. So we do use computer models to predict where the smoke will go. And on occasion, again, we do get smoke out of the Southwest United States. Let's talk water, because they need water in the Southwest U.S. The winter snowpack is a big contribution. Now, they do have underground, they have aquifers, they have reservoirs that they hold water in, but it highly relies on a significant snowpack. And it's changing. 21 years of data here, we're showing where the overall water content of the ground has changed since 2002. And as you can see, other than part of the northern plains, Montana, Wyoming, everyone else is dry, if not significantly drier. And the winters just aren't as bad as they used to be. They aren't as much seeing as much snow. So when you don't have winter snowmelt contributing, there's just no way to recover that water. Here's the overall groundwater supply. This is annual, so you see every year they get the winter refresh. But what do you notice about that chart? It's a lot lower now. It's clear. Again, I didn't draw the trend line, but you can tell there's a trend line going down since really 2010, and the variability is increasing. So it was always, -10 to +10, and now we're talking -30 to +5. So there's a lot more variability. So anything that relies on water, you just can't count on it coming next year, because it may not be here as it comes on through. Where are we getting more drought? As you might imagine, when we get less rain, we see more instances of drought. So while much of the country is getting more rainfall events, the Southwest, it's just not getting the overall water content that it needs. Here's the drought map. This is the current drought map. This is where it is right now. So, we're okay, but just about every other state in the United States right now has some level of drought. And in the Southwest U.S., we see these reds and even browns, which are D4. I don't like to call it exceptional, because that sounds like a good word. This is a really bad word. Exceptional drought is really, really bad and hard to recover from. So for the farmers in there, again, it's tough to recover from these kind of droughts. It's tough to grow crops, and much of the country is dealing with these droughts. And this shows when the snowpack melts, it's melting earlier. The problem with an early snow melt is that it takes its time. It's a slow snow melt. They need a rush. They need it all to melt in April or May. So it rushes down, we can trap it in the reservoir. When it melts early, it just slowly fades away. So it's it doesn't soak into the ground, it evaporates into the atmosphere. So these earlier trends in when it melts are causing issues. And then 85% of the Colorado River comes from just a small percentage of the Great Basin area. Colorado River is a significant contribution to the overall water supply. And as you can see, it's kind of split into the upper and the lower. So Colorado, New Mexico is in the upper side, and then Arizona, parts of Nevada and California are on the lower side of that. And you'll see two dams I'm going to talk about, the Glen Canyon Dam and then the Hoover Dam, which have some significant issues going on right now. The Colorado River has what's called the Colorado River Compact. This was signed about 100 years ago when all the states said, hey, here's how much you each can get. They signed it, allotting what's called 1 million acre foot. They had 18 between all the states and tribes, but it's only averaging 14 million. So there's already some problems there. And then since 2000, it's only averaging 12 million. So something's not connecting. It's been in the news because it expires soon, and so the states have been trying to get together, and guess what? No one wants to agree. So no one knows what's going to happen in the future. But it's certainly a significant impact because it's going down. There's less water going into the river.
One of the greatest lessons I ever learned was Steve Wynn sat me down and he said, Pat, we are a mirage.
You know what mirage means to me is seeing around the corner. It's sort of bending light.
Some people may think that we have plenty here to worry about, and that's the mirage. There are also people with the foresight to see that that's all it is. Because we have the foresight and the leadership, we have not followed the mirage syndrome.
The suggestion that one is a bit delusional, perhaps, about the availability of resources and the long-term sustainability.
My thinking is different from a lot of other people's, but the water that people think is there isn't really there.
I seriously disagree with that premise. I think that we are currently in really good shape.
It's a PBS documentary where it's the politicians are the ones who say everything is fine, keep moving and keep building in Arizona, and it's the ones on the ground say maybe everything is not fine. Here are the two dams that are, again, very, very crucial. The Glen Canyon Dam on the left and then the Hoover Dam on the right. Glen Canyon should be at 3,700 feet above sea level. They're running at 3,500 feet above sea level. If they get below 3,500, it no longer produces power. So they have 35 feet left of what's normally 200 feet worth to play with. And then once it's below 3,400 feet, it's called dead entirely. No water will come out. Same on the Hoover Dam. So it's normally around 1,200 feet. It's around 1,000 feet. It's got about 50 feet to go before it no longer generates power. And then another 50 below that, it no longer puts water out. So these are all not good things. They should be at the top. They're normally, again, 200 feet higher where they're at, and there's just no signs that that water is going to be recovered. These are numbers of last week, so there's no signs that those are going to recover because they're only going to go down. How has it changed over the past 40 years? You can tell. There's clearly something happening in our weather patterns that causes these to have less water. So if you're to simply say, don't worry about it, just come to Arizona and build, you'll be fine, this might tell you a different story. And then finally, dust storms. They're called haboobs. I don't know where the name come from. It's not a media name, but we call it dust storms in general. The football stadium, and you see the Phoenix airport. What happens here is, again, we talked about all that dry air. We get thunderstorms sometimes that just don't have much rainfall with them. So I'm going to show you a radar loop. This is actually the green and red are showers and thunderstorms. They're coming up out of the south. But you'll see towards the midpoint of the loop, you'll see a thin line that goes out in front of it. Right about there. You'll see that thin line surging out. That's the winds from the thunderstorm pushing out. So when you're standing out on the dock and you see a storm in the distance, you feel that cool wind. It's called the outflow wind. That's what's happening here. In this case, it's not bringing any rainfall with it. So when it comes across that dry, the ground with very little vegetation to hold the dust in, and there's actually was just a dust storm yesterday out in New Mexico, significant dust storm. You'll see again that there right there where it pushes out and goes right into Phoenix. Here's what it looks like from the ground. Not sure I'd want to take off in a plane jet. Glad that last jet finally decided it was too much. But significant impacts from that. Obviously, people are still driving into it. It's a fatality issue. It's just like our fog and our winter storms, where people drive in conditions they probably shouldn't drive. And oops, sorry, go ahead. Usually, well, they're again. It just happened yesterday in New Mexico, so it's something that happens every year in one part. Not necessarily that bad. Oh no, monthly. Yeah, monthly. Maybe not in Phoenix, but we probably see on average 4 days a month of dust storm warnings somewhere in the Southwest U.S. So along those lines. So speaking of winter storms, I didn't talk about that yet. They get winter, and not just in the mountainous areas. It's in regular areas as well. It doesn't have to be a ski resort. One of their biggest events was back in 2015. It impacted almost all of Arizona, New Mexico, even part into Texas. Places that get 1 inch maybe of snow a decade got 1 to 2 feet in a day. So obviously not prepared for it. Here we're looking at Odessa, Texas. That's the Weather Service office that covers it. But you see 24 inches just west of Carlsbad, New Mexico. These are all significant records for that area as it moved on through. Some pictures that look more similar to maybe an Ohio blizzard than what we might expect into parts of New Mexico. My favorite here, again, they normally get 1 inch a decade. And then this is what it looked like after this winter storm came through. And they get the remnants of hurricanes. This is Norma. Norma was 1970, came in off the Pacific. It was a strong hurricane over the Pacific, kind of weakened into a tropical storm, made landfall twice. It hit Baja California first, and then made landfall. But when it came to the United States, it wasn't a hurricane anymore. It was just all that precipitation that came out. So 24 deaths in the Southwest U.S. as it moved on through. Here's a satellite imagery. You'll see some flashes. Those are lightning pictures as it went on through. But you'll see this storm as it comes on through, hits the Baja Gulf, hits the next Gulf, and comes across, and just sits there for a couple of days then. So this rainfall just sat, and it just continued to rain. This is not monsoon. This is the remnants of a hurricane that got stuck over the Southwest U.S.
This was the deadliest storm in Arizona history. It was at the time, and it remains the deadliest even today. It was Labor Day, 1970. And so there were a lot of people out camping. There were a lot of people out doing things, getting that last big holiday in. And the weather forecasters started noticing a couple of things happening just a couple of days before the Labor Day weekend. One was hurricane and then tropical storm Norma, who was down in the eastern Pacific. Norma was starting to send moisture up from the southwest. And meanwhile, there was an unusual early fall cold front coming down from the northwest. And the model showed those two systems, the moisture and the cold front, colliding somewhere over the Four Corners area. And that's what happened. And over the Labor Day weekend, it started to rain. It turned into the most rain ever recorded in 24 hours, which was almost 11 and a half inches up in Gila County near a place called Coles Ranch. And by the time it was over, it turned into the rainiest, but more importantly, the deadliest storm in Arizona history. There were 23 people who died. The worst event took place on the Tonto Creek area above Payson, and there was a bridge that went across the creek, and there were some people trying to escape from a campground there. And as the cars waited for a chance to get over, a 5-foot wall of water swept down through the creek, and it swept the cars off the bridge, and there were 12 people killed in that incident alone. The power of the water was probably unbelievable for a lot of people. It swept away entire cabins. It swept away full-grown ponderosa pines, 8-foot boulders. Water levels, they said they could see up as high as 24 feet on a tree. They could see where the bark had been scraped away. And the USGS, the U.S. Geological Survey, went out and looked at some of the damage, and they found little bits of sandstone embedded in pine trees like projectiles, because the water had just been coming at that sort of rate.
Yeah, so again, they get it. The same spots that go through droughts, and they get tornadoes. Very, very rare. This was a day where 4 tornadoes formed. Some of them were quite long-lasting. It was an October event, a very strange setup. We had a low-pressure system coming in off of California. It brought, again, moisture out of the south, out of the Gulf. That combined with some issues to create some thunderstorm and some tornadoes. Tornado 2 there went on for almost 20 miles before it was all said and done. So the same type of stuff we might see. They had some baseball-sized hail. Again, this is very rare for them, but I just showed you how snow is very rare for them as well as it went on through. So that's the Southwest U.S. Again, fascinating stuff. I know we say here, wait 5 minutes and the weather changes. I think they might have us beat some of those times, but hope you enjoyed the talk. And John's going to pass around the microphone if you have any questions or comments.
Hi, I was wondering if there's an area of the country that you consider safer than the others, even though I want to get there right away.
You know what, flash floods, I'm glad we don't have flash floods. Let's put it that way. Those are the ones that scare me the most because you don't, as I said, the people leave, they had to leave the canyon. Texas last year with the girls, the girls camp, same story. These are most flash floods happen in areas that don't have a lot of communication, so we can't, even if we knew it was coming, we can't tell you because obviously a lot of people live in those rural areas for the reason. So I'm glad, hurricanes are one thing too, but I'm glad that we don't deal with real much flash flooding in this. We get floods, they're annoying, but they don't kill you, so that helps.
And one more question about the dust storms. Mm-hmm. How much warning do you get for those?
Those are pretty good because we can see the thunderstorms moving through and the satellite imagery now. Back when I went to Purdue for meteorology, that was in the 80s. Back then, we would get a new satellite picture every 30 minutes. So the pictures I showed you with the loop, that was every 30 seconds. So we get them every 30 seconds now in big events. So we can see actually the dust on the satellite from above before it moves through.
Thank you. That was very interesting. So what do air traffic controllers do when this is coming? You saw the airport with them. Are they on the Weather Service automatically?
Yep, so they'll push out as long as it's clear the way they're going, they'll push it out. My concern as a person is what happens if that plane has an issue and has to return. It's not coming back to Phoenix Airport. So that's the concern. So again, it's a balance of keeping things moving because they've had it before on the same token. Again, eventually at some point you see that one got on the runway and then turned off and came back. So eventually they said it was too much.
What's your feelings about the Chinese seeding clouds for irrigation and farming?
Yeah, cloud seeding has been difficult to show. Meteorology is a weird science. Like if you mix hydrogen and oxygen in a chemist lab and it doesn't come out right, you can grab some more hydrogen and oxygen and do it again. We can't do that in meteorology. So what we do is we simulate the atmosphere, then we will seed small areas and see if that helps. There's not been convincing evidence that it does a major thing, but there is some signs that it does something. There's cloud seeding in the Dakotas, in Texas, Utah. They're trying everything. The Pacific Northwest, they have drones now that are doing it. That might be an advantage because you need some sort of bad weather for the cloud seeding to work, but if it's too bad, then planes can't fly in it. So now with drones, I think that we'll see some science come out of that when we put drones in and measure exactly what's going on in the clouds. So there's potential, but still it needs something in the atmosphere already. If you just cloud seed it a sunny day, the seed's just going to drop to the ground and do nothing. You have to have clouds, and we're finding that there's fewer days with clouds in them to dry.
So the talk frames the Southwest as kind of an isolated block, but it's obviously embedded in larger systems. Are there bigger structures that help us understand why the Southwest is evolving this way, like El Nino perhaps? Or
so what we're finding is the jet stream is not becoming as potent as it used to be for whatever reason. El Nino also has an impact because when it does, El Nino is basically a warming of the waters that causes its own high pressure system. So if it pushes the jet stream away farther, we need the jet stream. If we don't have the jet stream, we're not getting a lot of active weather. We're not getting storms. Like right now, the jet stream is not near us, so it's been quiet for the last couple of days. Next week, the jet stream's going to kind of ride right over us, so we're going to see some storm action. So depending on where that jet lays up, and again, we don't know why the jet stream has moved, but it's not acting like it used to act. So whether there's some natural, there's some not natural things going on, we just know that it's the biggest impact is in the southwest U.S. The jet is just not going that way anymore. It's either going to the north towards the Pacific Northwest, or it's staying down in Mexico. Florida's getting a lot more action in El Nino, La Nina years because the jet stream goes across Mexico and hits Florida. It misses the southwest U.S. So the whys are kind of hard to say. We're just observing that something is changing.
Yeah, I had two questions. One is about the rattlesnakes. That area is full of rattlesnakes, and why aren't they affected by this? And the other thing is the weather balloon. Why do they have to have the satellite tie-in? What does the satellites do for the weather balloon?
I am not a rattlesnake expert by any stretch. I think that's cold-blooded. They don't care about the heat, but I'll let someone else join in on that. For weather balloons, what we do is we launch them twice a day. In the old days, what would happen you would have to use the azimuth, I don't remember the name. You had to watch it and you track it, and you could track the angle and see how high it goes, and it would radio back the temperature. Now, because it's GPS controlled, we don't have to manually track it. It tells us where it is, how high it is, what the temperature is and the dew point, and then we can plot it. But in the old day, literally there was someone watching the balloon go up into the atmosphere and tracking its elevation to see how high it was. Now the GPS does all that for us. It's kind of like a driving, it's Google mapping us as it goes into the atmosphere. And actually, there's hobbyists that have little scanner radios that can listen to that signal, so they can plot on their own, they can do that. So it uses the GPS just to say where it is, similar to a plane. About 120 across the United States. So Detroit is the closest one to here. Gaylord, Michigan, Covington, Cincinnati area. So they're scattered. They're not quite as widespread as Weather Service offices because they cost money and they take resources. A lot of offices are now automating that. So actually, you saw 2 people launch that one. The Detroit office is totally automatic. So they press a button, it inflates it, it opens up the roof, and boom, goes out. So we're trying to spread. They're so small that by the time they get up there, if it were to hit, it's just a nylon balloon. The box itself is made out of styrofoam, so it would not be a factor, but it's never happened, so not saying it couldn't happen, but generally speaking, the one in Detroit, because of the way our winds are, it always goes off into Canada. Same with, they generally speaking don't. The one it's in the Cincinnati one is in Wilmington, which is east of the main Cincinnati airport. So generally speaking, the winds blow it away from traffic patterns.
It just lands in some random place, that could be somebody's backyard.
Absolutely, yeah. Actually, I meant to bring one. Last month, I had a friend of mine, colleague in emergency management, called me and says, Rob, I'm fishing up by Traverse City, and I caught something that says it's a weather instrument. And he reeled in, he brought it back to me, I cleaned it up, so I have an old used one. In the old days, they actually asked to send them back because they cost like $300 back in the old days. Now they cost $20. So the postage to send it back isn't worth it, but they would rehabilitate them in the old days. But now everything biodegrades except for just a couple of the sensors that are left.
You don't drive out and pick them up.
Not anymore. Nope, don't care anymore. They're again, most of the balloon entirely degrades, and then most of the package biodegrades, and it's left with a couple of transistors and a little mini, very small transmitter. So.
Has the change in the weather affected the water here in the Great Lakes very much? And also, second follow-up on that, what about the Southwest looking at our water?
Yeah, so the Great Lakes do not change in the same way. We do have patterns. There's generally a 7 to 10-ish year weather pattern, but we really haven't tied that in. Our lakes are more sensitive to winter. If we don't get a lot of snow in the winter, much of our water comes out of Lake Superior. So if we don't get a good snow in northern Michigan, that's the years when we'll see some down lakes. Was it 3 or 4 years ago, lake levels went down. The other issue is when Lake Erie is not quite as significant. Lake Michigan is big because of the dunes. When the lakes go down, people think, oh, I can build closer to the lake. And then what happens 3 years later when the lake comes back up, then they came to us and said the government should pay for us to fix our house. Like, no, that's not how insurance plans work. So yeah, that's tough. The Great Lakes Initiative, it was about 20 years ago, and every 2 or 3 years, someone from Arizona says, why don't we just take the Great Lakes water? That never goes anywhere, thankfully. It is a proposal to pipe water out of the Great Lakes, but I don't think anyone in the Great Lakes is ever going to let that happen.
Related to the other question, how is El Nino expected to affect Michigan and Ohio and any other jet stream issues that might be happening?
Yeah, El Nino is tougher for us. El Nino has a big impact on the West Coast and big on Florida. What impacts us is La Nina. When we have a La Nina winter, we're usually getting a less severe of a winter just because it moves the jet stream farther north yet, up into Canada. El Nino, there's a tougher connection for the Great Lakes to say. So generally speaking, it's not as hot of a summer in El Nino years. There's other things that factor in. There's an Atlantic version of an El Nino. It's called the AO, the Atlantic Oscillation. So really, when we don't look at just El Nino, we look at that. And then there's called the PDO, the Pacific Decadal Oscillation. Every 10 years, the Pacific flips its temperatures for some reason. We don't know why. So there are more that factors more into our weather than El Nino does. Oh, young lady in the front? No. All right. She got scared. That's okay. I scare sometimes. So. It's my niece. I'm allowed to make fun of her. Anyone else?
Yeah, just curious on how the thinking goes for how much sampling of the weather you're going to do, and can you do better forecasting with more dense, more often sampling, or is the limitation something other than the sensing inputs?
Yeah, I want as much data as I could ever possibly get. I didn't show the map from last time because that got a lot of contention, but due to cutbacks made by the federal government last year that have a 4-letter abbreviation that you can pretend on your own to know, about 30% of the observing sites were cut last year for those balloons. So instead of sending 120 up twice a day, we send around 50 in the morning. We send another 40 or so in the afternoon, and then another about 100 in the evening, and then 100 and about 40 then overnight. So instead of having twice a day 120, we scatter them out because of the cutbacks that were made. So that has had a big impact on our forecastability because we need the data. What is helping is we're now putting these instruments on jets. So as Delta does it, American Airlines, as they fly into and out of airports, they send the data back. So the good news is it's more frequent. The bad news is it's not as thorough. You know, if you're flying into Detroit Metro a couple times a day, it's not as good. So we always want more. We're trying to find different ways, but the balloons have stood the test of time of launching it directly in. We've got the same sensors. We know the data. We would love to have more of it. I kind of mentioned this. We don't have an official rain gauge in Lakeside here. So we don't know exactly how much rain fell those times. We can make some estimates, but we don't have anyone with a 4-inch wide, 8-inch tall official rain gauge to tell us, and we would love to have more of that data available.
I know this isn't in the north southwest, but closer to us, the Johnstown flood that happened in 1899. Just a fabulous museum if you've never been there. I mean, it really tells the story, and it's very heartbreaking. You did a super job with what you did. But there's a story of a flood that happened, not a one that killed people, but it was a flood, and a lady and her dog were sitting on the roof waiting for the fire department to come to get her off. And there was this ball cap on the water, and it was just moving real slow, maybe 12 feet this way, and then it turned around and it came back this way. And the dog was fixated on this ball cap. And the fireman said to the lady, well, what's with your dog? What's going on? She said, oh, God, that's my husband. He said, come hell or high water, he was going to mow the lawn today.
Johnstone is a fantastic book on that story that I've read that is impressive. I didn't know they had a museum, so thank you.
Thank you very much, Ron.
All right, good way to end on. Thanks, everyone. appreciate that. Thanks.
Taking some of these issues are politically explosive. I noticed you dancing around them, so I just.
I have to.
Hi, I'm Harrison.
Harrison, nice to meet you.
Yeah, so I just wanted to ask this because I didn't think it would be appropriate
Sure.
to talk about in front of it. Have you, do you work as a consultant with reinsurers or insurers by any chance? Because I'm considering starting a career in catastrophe bonds specifically.
Yeah.
And so I just wanted to understand like what would be the fundamentals I would need of meteorology, of weather forecasts in order to prepare myself.
That's actually a big area that AI is being used in. So when I talk to people that want to be meteorologists today, I say you are not going to forecast tomorrow's weather.